In this lesson, we will examine the use of radar as an approach aid. The use of radar for such a procedure is called a radar-controlled approach. A radar controller will simply talk the pilot down the approach by giving heading and height guidance as the controller sees it on his radar screen. There are two types of radar-controlled approach. The first is a precision approach and is called the Precision Approach Radar, or PAR, and the second, a non-precision approach, is called a surveillance radar approach, or SRA. In both cases, the radar controller provides radar-derived information to the pilot to permit the aircraft to be flown along a predefined track, and, in the case of precision approach radar, a defined glide path. For a surveillance radar approach, a recommended vertical profile or virtual glide path is published. If radar contact is lost for any significant period during the last 2 nautical miles of a radar approach, the pilot will be advised to carry out a missed approach procedure. The following are the general procedures applicable to both types of radar approach. Before a radar approach can be initiated, the pilot must be informed of the runway in use, the obstacle clearance height or altitude, the angle of the glide path and approximate rate of descent required to fly the approach, the loss of radio procedure. If, for any reason, a radar approach service can no longer be offered, then the pilot is to be immediately informed. The aircraft may continue the approach if a non-radar procedure or visual approach can be achieved, but if this is not the case, then the approach must be terminated and a missed approach procedure executed. Because this procedure is also the very last part of the approach, it is important for the aircraft to be correctly configured to land. Therefore, a pilot will be asked to confirm that he is selected under carriage down. A radar controller is required to notify the aerodrome controller when an aircraft making a radar approach is approximately 8 nautical miles from touchdown. The aerodrome controller may issue a clearance to land or state that such a clearance will be issued subsequently. Should clearance to land not be received by the radar controller by the time the aircraft has reached 4 nautical miles, then the aerodrome controller will be asked again for clearance to land. In any event, clearance must be issued by the aerodrome controller to the radar controller for onward transmission to the pilot before the aircraft reaches a point 2 nautical miles from touchdown. Should a radar controller believe that an approach has become dangerous, for instance because there is conflicting traffic, the pilot shall be instructed to conduct a missed approach procedure. If the approach is considered dangerous because of conflicting traffic, clearance to continue and land has not been issued, the aircraft is dangerously misaligned from the approach path. The radar controller will advise the pilot to go missed under the following circumstances. It appears that a successful approach cannot be completed. The aircraft is not visible on the situation display for a significant period after it has reached 2 nautical miles. During the final approach, the position or identification of the aircraft is in doubt. Any instructions from the radar controller concerning a missed approach are to comply with the published aerodrome missed approach procedure. We will examine the precision approach radar first. This is specifically engineered radar equipment that provides very accurate precision, azimuth, and glide path information to a dedicated radar controller. Whilst providing a PAR service, the controller will be engaged in providing the service to one aircraft and will not have any other duty. The pilot will be passed azimuth, right or left of track or heading information, and elevation, on, above, or below glide slope. This information is provided to ensure that the pilot can fly the aircraft along the predetermined flight path. The pilot should not respond to left or right of the centerline because the controller will direct any alterations in heading. However, it is his decision about deviations from the glide path. For example, a typical controller communication might be 4 miles from touchdown, left of centerline, turn right 5 degrees, slightly below the glide path. The pilot must turn right to follow the controller, but will make his own decision about rate of descent. The service will continue through the point the aircraft reaches the decision altitude or height. At OCAH, the pilot will be informed that radar service is terminated, although distance to touchdown and position relative to the ideal approach path should continue. Because the information is passed in the form of a continuous talk-down, the pilot must stay on the precision approach radar approach frequency. As we know, the radar controller is responsible for obtaining a landing clearance from the aerodrome controller. To recap, normally this will be done at 4 nautical miles from the threshold of the landing runway, but may be delayed by the aerodrome controller until 2 nautical miles. If no clearance has been received at 2 nautical miles, the pilot will automatically begin the missed approach procedure. Throughout the approach, the flight crew should cross-check the position of the aircraft against the precision approach radar information, for instance using ILS or DME and RAD-ALT information. In the UK, PARs will not generally be found at civilian aerodromes. However, the new generation of PAR equipment is widely installed at military aerodromes. If you would like to hear an audio commentary of a precision approach radar procedure, click on the audio button on the bottom right-hand side of the screen. Click the forward continue arrow when you are ready to proceed to the next teaching point.
Golf Alpha Bravo Charlie Delta, radar contact 19 kilometers from touchdown, continue heading 200, do not acknowledge further transmissions. Charlie Delta 17 kilometers from touchdown, left of track, turn left 5 heading 195. Charlie Delta 14 kilometers from touchdown, on track, turn left 5 heading 190.
Having briefly examined the precision approach radar service, let us now examine the second type of radar-controlled approach, which is the surveillance radar approach, SRA. It requires no special equipment in addition to a standard surveillance radar system normally located at the aerodrome. As a result, it is less accurate, and the controller cannot verify glide scope indications to the pilot. The only approach control that is given is azimuth. Because of this, a surveillance radar approach is a non-precision procedure. The surveillance radar approach procedure is similar to the precision approach radar procedure, except that in this case, advisory height information is passed with range information. Therefore, during the approach, the controller provides magnetic headings and corrections, either left or right, to keep the aircraft on the runway centerline, but can only pass advisory height information to assist the pilot in his descent planning. For example, slightly left of track, 5 miles from touchdown, you should be passing 1,550 feet. Like the PAR, the procedure will end at OCAH. However, the procedure will automatically terminate at the Radar Termination Range, RTR. This is the range at which the radar service will be automatically terminated. Typically, RTR2 is used, indicating that the radar service will be terminated at 2 nautical miles from the threshold of the landing runway. If the RTR is 2, distance information is passed, with advisory height information, every 1 nautical mile. If RTR1 is applicable, range and height information is passed every half a mile. As for precision approach radar, The radar controller will be responsible for obtaining a landing clearance from the aerodrome controller and passing it to the pilot. If you want to hear an example of a surveillance radar controller talk down, click on the audio symbol button in the bottom corner of the screen.
Boxer 55, this will be a surveillance radar approach to runway 29 terminating at 2 miles from touchdown. Check your minima, step down fixes and missed approach point. Check wheels. Boxer 55 approaching 6 nautical miles from touchdown. Commence your descent now to maintain 3-degree glide slope. Do not reply to any further instructions. Slightly left of track, turn right 3 degrees, heading 292. Approaching 3 miles from touchdown, you should be passing 950 feet. Closing to final approach track, turn left 2 degrees, heading 290 to maintain. On track, heading 290. Boxer 55, surveillance radar approach completed. Contact tower 119.25.